Hello, my code minions. Welcome back to another episode of Conquering the JavaScript Interview. As we traverse this vast landscape of JavaScript, we're going to be delving into the core of its native functionalities. Today's spotlight shines on the filter method, a staple for JavaScript developers and one tool that I happen to overuse constantly. But nevertheless, it's a cool one to not only know, but also to know how to write yourself, which I think is important. So you want to refine your arrays to perfection, then we're going to filter on through. This little mini-series, Array Architects, is based on an idea a co-instructor here at Covalence, and I had about trying to take some of my algorithm and data structure videos and packaging it into a course for our students to go through that takes them through this with a companion repository and additional videos on, interview prep, portfolio prep, LinkedIn stuff, and things like that. That kind of more nebulous stuff will be available in the course. I'm going to keep all the algorithms and data structures for free here on YouTube, so never fear. But if you're interested in that course, as well as our front end and back end course that combined make our full stack program and one of my favorites, my standalone React advanced course, then consider looking in the description down below for a link to our community membership. For $25 a month, you get access to all those courses, any future courses I or my instructors and content creators here at Covalence happen to make, as well as access to our Discord where you can get real-time, pretty prompt and snappy responses to anything you work on through in our course in terms of JavaScript, TypeScript, React, MySQL, Node Express, all that kind of fun stuff. So if you have interest in custom content like this, it tends to be inspired by student questions that I get asked. Again, check the description down below for a link to that. Otherwise, let's talk about filtering. So the filter method was introduced with the ES5 specification of JavaScript somewhere around December 2009, according to my brief research I did before this video. Its main purpose was to provide developers a built-in functional way to generate a new array containing only the elements that satisfy a certain condition, right? So in everyday coding and all of my coding, because I look back at a lot of my projects and I tend to use it everywhere, filter is extensively used to create a subset of an existing array based on specific criteria. Whether you're refining search results, displaying items that meet user preferences, something that I do all the time, or eliminating outliers from datasets, filter is going to be your go-to tool. So the way the filter algorithm works is that we're going to start with an empty result array. We're going to iterate through each item in the original array. We're going to apply a provided callback function to each current item or element of the array. If the callback returns a true or truthy scenario, we're going to take that current item and add it to our empty subset or result array. We're going to continue until all the items are processed, and once that is done, we return our resulting array that should only, again, contain the elements that satisfy that condition. There are, as with all things, pros and cons of using filter. I'll talk a little bit about that and performance and things like that near the end of this video, but remember, immutability is a big fun one, especially if you're a React developer. You are very familiar with this term, and if you're not, you should be. And again, check out my React course if you have interest in learning more about that term and how it relates to React. Immutability means this filter array method returns a new array instead of modifying the original, right? And that is a very important concept or principle in functional programming in general to understand about immutability, right? I tell my students it's like a flip book. You do not erase each page as you draw it. You take the next page and basically, you can make a copy of the previous with a small alteration. So over time, you get an animation in the flipbook of this karate chop for some reason I'm doing on camera here. Instead of erasing every single page and winding up with nothing at the end other than a really nasty looking page. So again, immutability is a big concept to understand. Readability, I think filter is super readable than using traditional for loops, but again, your mileage may vary on that one. And on top of that, you can chain. So you can do a lot of cool array chaining because filter can be seamlessly chained with any other of the array methods for really concise, cool looking operations. That's when you really showcase that you know your stuff, when you can actually chain multiple array methods together. But I will say that cons, I said readability is a pro of using filters. Some individuals don't like the unnecessary arrow and ternary. Sometimes they get involved in a lot of the ES6 shorthand that's available. So it could also be a con readability, pro-con situation there, as well as performance. Anything that uses callbacks during these things are technically a little bit less optimized in performance critical situations, which I'll talk about at the end of the video. So yeah, let's see. So like the prompt says, we're going to be basically implementing our own version of the array prototype filter. We're going to call ours custom filter, and I will say that you probably should never actually mess with prototypes in a production code base, as it can cause a lot of wonky or unexpected results. But nevertheless, let's go ahead and start coding. So so if I want to modify or add my own custom filter method on here, so we're going to be implementing our own version of this. I'm going to call ours custom filter so it doesn't override or clash with the native filter method that currently exists. So we can take the array interface here in JavaScript, and we can tell it that we're going to be adding a new prototype to this array constructor. We're going to call it custom filter. Okay, custom filter is going to be a property of all arrays in this current code base. This is not going to affect all arrays everywhere, just the ones in this file in particular. And we're going to assign it an anonymous function that's going to do some work for us. So if I call custom filter, it's going to run this function. And if I want to pass some custom parameters to the custom filter, we can say, well, just like our native filter method takes a callback function that takes that condition we want to satisfy, and we're going to call that our callback. So we're going to pass in the function that will generate our condition for us. Okay, so like I said before, the filter method returns a new array for us. So I'll go ahead and make an empty array, and we know that after this thing is done, it's going to return that resulting array no matter what. So we already have our 2 lines of code written for it already, just like that. So from here, we're going to have to iterate over each item of the array, and we're not going to be using the array filter method since we're implementing our own, so we have to use a traditional for loop. So I will go ahead and write our for loop here. This is just, classic stuff. No, oh yeah. So we don't have like an R or array argument. In this case, because we're implementing our own native method, remember, this method will be chained onto an array value of some kind, meaning that if we want the context of what we're filtering over, aka the keyword this, the keyword this in this context, my God, I hate trying to define this word in JavaScript, the keyword this will grab its context from the thing furthest to the left. So for example, if we come up here on this array and I wrote custom filter on this array up here as this demo, then this would be the thing furthest to the left of the dot, which would be this, aka the array I'm custom filtering over. So this dot length will represent the length of the array. This is our little getter property accessor right here. This dot length means array dot length. And then we're just going to iterate one element of the array at a time. Then we're simply going to provide a condition that says we're going to push in the result of the array to our results array. We're going to push in the current element we're iterating over, represented by this square bracket I. We're going to push that into our result array if this condition is satisfied. Now remember, we are passing in a function as a callback here. So here's what we got to do. We're going to provide our callback. We're going to call our callback. The callback, just like the filter method, should have access to each element if we need it, the index position if we need it, and the array itself if it is needed, right? So that means that we're going to have to pass in 3 args here, because remember, that's what filter can do, like filter. I wonder if I can do this really quick. Let's just do one filter. Because I should be able to bring up the MDN docs, just look right here. Yeah, we have access to the value, the index, and the array itself. Those are the 3 parameters that we have access to in our callback, and we're going to be mimicking those parameters as well. So we're going to say the element itself we know is this square bracket I, the index is just I, and the array is this. So this 3 argument setup we have here just mimics exactly what the majority of the array methods already do in native JavaScript. We have access to the element, the index, and the array itself, should we need it, inside of our callback to do some more crazy looking code. But believe it or not, this should be easy enough to get exactly what we need going here. So I'm going to go ahead and let's do a console log. Let's do some testing here. Let's see. I'm going to grab my array of 1 through 10, which I think all 3 of my demos here use, because again, it's really obvious if it's working or not. We'll say input R is our array here, our condition. We could either do inline or as a function here. I'll probably just leave it simple like this. And we'll say input R because this is more like what you probably are used to seeing when it comes to these. So custom filter should be an array method that we have added to all arrays in this current code space. So I should have access to it. We're going to pass in saying, hey, take each number of the array that we're filtering through, and for each number, let's see if they are even, as I think my first test. We're going to say return any number who is even in this array filter. And wouldn't you know, take a look at that. We got 2, 4, 6, 8, 10, which is indeed our filter of even numbers here. The other two, again, the demo doesn't really matter. Less than 5, greater than 7. So let's see if it works here. If num is greater than 5, does this produce the correct results? 6, 7, 8, 9, 10. It sure does. Or rather, less than 5. It doesn't matter. 1, 2, 3, 4, greater than 7, or something like that. Just trying our less thans and greater thans just to make sure it works the way we expect it to. Yeah, okay, so I know that kind of happened fast right there as I was just like changing these values, saving and relogging the file right there, or relogging the results, but I think it's pretty obvious that this sucker is working, and that's really all there is to it. This is our own custom filter native method that is the implementation with the same kind of specifications that the native filter method is. And I think that these little exercises, I'm gonna make this little video series on, I'm gonna call it like array architects or something like that, is really cool to know. It gives you a greater understanding and a better mastery over some of these methods that we use day in and day out. I can't tell you how many React developers use the array map method thinking it's somehow important to React when it's just literally just an array that returns a new array with a function callback over it, which might be the next video, who knows. But yeah, that is our filter method right there. So like I said, we start with an empty result array. We begin iterating through the original items of the array. Remember, the this context comes from the thing to the left, which happens to be our array itself, more than likely, unless we're doing this incorrectly. Then we're going to apply that callback in this condition. So for each item, the callback function is invoked. If the callback returns true, the item is added to the result array. And then finally, once all elements have been processed, the resulting array is returned, and the new array contains only the items for who the callback is true. And we have tested that on several occasions and seen it to be for real skis. So yeah, I would say that in the real world, you generally do not want to do what I've done here, which is modify a new prototype onto all array constructors. That's because this has really unexpected results in large code bases and things like that, and you're not going to be able to have new developers join your team and know what the heck you're doing here. So I wouldn't recommend ever doing it this way. I think it's cool to know that you can do this, but I wouldn't recommend it. So if you needed something more standalone and modular, obviously just a traditional function could do the job as well if you needed to. So function custom filter func would take an array and a callback, and it would do the exact same thing as this code up here, except instead of this, we just have our own array argument. So instead of this dot length and this, we would just do the following, boom, array like that, and our callback argument would still be the same thing. So let's make sure that this can still work in this particular use case. So I would say copy paste that. We're gonna say down yonder. I like how I copied all that just for a console log. That's stupid, Luke. Come on, man. Input array will be the first arg, and then the second arg will be that callback function that will be the same thing, greater than or equal to 7, and console log. Yeah, so just making sure that it still console logs the same thing. So there's our callback. There is our input array. And there's our custom filter function, which would be a better solution than modifying a native prototype on here. So yeah, don't do that. It's just cool to know how to do. It's also something you might get interview questioned on. You never know. If they ask you to, if you use like a filter method or something like that, they might quiz you to see if you actually know how to write one vanilla, which is what this series is intended for. So finally, to round out this little video here, I want to mention something interesting about performance, because a lot of students tend to take this for granted because they don't tend to work with data sets that are this large. But let's goof off and learn something new here, right? So generally, using callbacks is going to be a less performant way than an optimized for loop, no matter how small those optimizations might be. So what I would like to do today is make a large array of some kind. We're going to make an array from... And let's make a length of 1e6, which will make an array that will be 1 million numbers long. And this array from is going to take some args here, and I'm going to say we're going to we don't have any elements of the array, but I do have index positions. And we're going to make this array numbers 1 to 1 million. So I'll stay, because the index starts at 0, I'll go ahead and just add 1 to it. So now we have an array of 1 million elements. Let's see if this is true. I'm not going to console log it because I have no idea. Well, you know what? What's going to happen? What's the worst that can happen? It crashes. Ah! Yeah, so we have an array of 1 to 1 million. Let me just do its .length property instead. There we go. Uh-oh, it looks like it's bugged out a little bit here. There we go. Yeah, so we have a good old 1 million array elements in this array. So we have 1 million things we're going to iterate over. And given modern JavaScript and computing power, I don't foresee this being a super long or iterative process here. Let's go ahead and write 2 different ways here. So I'm going to go ahead and write a function called filter even numbers using filter. That is an insane, crazy name right there, but it does get the job done. So there is our filter even numbers using filter, because that's what it's going to be doing. It's going to return our input array, just the native filter method as is, that uses this callback syntax as well as our very same test to make sure if numbers are even, return them. I'm going to write a function called filter even numbers using loop, which is technically the more optimized solution. So here I'm going to just write, I should have copied and pasted the code before I deleted it, but c'est la vie, folks. We're going to do a little micro optimization here now. Right, so hold on. I'm going to make a comment on this here in just a moment, but let's just go ahead and write out the code that we know. And again, rather than passing in a callback, hard coding the condition itself is going to be a better solution here. We should see even a few milliseconds difference between these two over the span of a million elements. So return a result. There we go. So I have my 2 functions, one that uses the callback syntax of the array filter method, and one that's a traditional written for loop. Now, modern JavaScript engines are packed with stuff under the hood that happens, including optimizations that you may not even realize. For example, I'm fairly certain that all modern JavaScript engines, most of them are just V8 these days anyway, will actually cache this .length property so it doesn't have to constantly access it. Because remember, on every iteration, it would have to test this condition and also access the property length on our array every single time. And that will be like, well, why does it need to calculate the length of the array every single time we iterate over an element? That seems redundant to constantly recalculate it. Now, again, more than likely, it will just cache that result and remember it for us. But if you want to write mindfully optimized code, we can even say, I can make a variable that is the length of the array. So we can do a shorthand. Thank you, Percival. My cat decided to come join us. The one in the thumbnail. Say hi, buddy. Hello. So sweet. So sweet. Okay. So this is like something that already kind of happens under the hood. I make a comma separated variable list in my for loop that generates this variable here. Technically, one time it accesses the length of the array, and the condition now doesn't have to constantly recalculate the array length, even though it never changes. So yes, in modern JavaScript, this is probably already done for us under the hood, but again, writing mindful, micro-optimized code like this very clearly states our intentions, and it gets you thinking in a very hyper-optimized kind of way. Should this be an interview type question you get here? So there you go. That's a cool thing to know how to do. All right, so I have my 2 functions now, and let's go ahead and do some console logging here so we can see any kinds of results. I'm going to do a console dot, oh my god, how did I typo that bad? Console.time, we'll call this filter method. That would have been a way better function name, Luke. Yeah, what are you going to do? We're going to run this function filter even numbers using filter of our large array. Okay. And we're going to do a console.time end of filter method. So basically, this will console log the start time before filter method, run filter method, however long that may take, probably in the range of 10 to 20 milliseconds is my guess. Console time end is filter method, just another message that will log the end time. I'm going to copy and paste this code down yonder and change it from filter even numbers using filter to using loop. And then for these two messages, I'll switch to filter loop like that. And there we go. Then we're going to have some console logs appear fairly quickly up here. I'm going to save this file. Get ready, y'all. Let's see if there's a performance difference. And there is. Now, you might be thinking, Luke, 7 milliseconds-ish doesn't seem like a long time, but, we're filtering through an array of a million numbers. Imagine we have objects or more of a crazy data structure or something, it doesn't really matter what it is, but the longer and more complex the array gets, the worse performance our callback syntax will have compared to an optimized for loop. So this is part of the little array architect series. I want to throw this little content in here because otherwise these videos would be kind of short, which honestly some people enjoy. I don't know. I feel like brevity is the soul of wit, but brevity is not one of my strong suits. But yeah, I think this is good to know, right? So this little optimization right here is this classic interview stuff that you possibly might get asked. Probably not as a beginner, but if you begin shooting for positions that aren't just explicitly written as beginners, this kind of stuff, again, it just makes you a better coder, and it adds yet another tool to your tool belt, as with all things we learn on my little algorithm data structures series here, where, we just improve any way possible. So I want to thank y'all for joining me today as we witness deep diving the logic of native functions like filter. Not only clarifies how JavaScript operates, so you learn more about what's happening under the hood, but it also empowers you to craft more optimized solutions. So sharpen your tools, embrace the logic, and until next time, do this YouTube stuff like comment, subscribe. Make sure to check the description down below for a link to our community membership and a link to a CodePen that'll have this code written inside of it. And don't forget to, have some happy fun times coding. See y'all in the next one.